I'm CK, and tonight's another You Know Better Than CK What He's Going to Build, because I got a couple of boxes from Thonk, where I buy my eurorack accessories, thonk.co.uk. They're out of the United Kingdom, and they provide really good service and really fast service to me in the United States, so I continue to use them. I have 2 boxes from them, and I know what's in them in total, but I don't know what's in this one. So we'll open this up and see which module we're going to start building tonight. Hope you enjoy it. And here's our box. Get an X-Acto knife and cut her open. Again, I really like buying stuff from Thonk. They very responsive. The kits usually come with very good components. I've bought from some others that the components that came with the kit were not necessarily the best, but I have had no issues with Thonk at all, except trying to figure out how to open a box, like right now. Okay. Somewhat typical Thonk packaging, some nice recyclable packing material, so that's good. No bubble wrap, which is a bane on the world's environment, but lots of nice tissue paper and crumpled cardboard. That's good. So this, this is, first we get rid of the box. This is a Division-6 dual mini sequencer. I didn't have a good sequencer in the rack out here, so I decided to buy this. And this looks like it's going to be a multiple night project. And again, it comes out of a Division-6 out of New York City, and it's 2 sequencers. And I believe you can, besides being able to store patterns for each, I believe you can trigger the second sequencer from the first sequencer, and so on. So we'll be looking forward to that when we get it all assembled. Let's take it out of the packaging now and see what we have in the bags. So as you can see here, this bag contains the front panel. Nice front panel. It's wide, as you can see. Whole bunch of LEDs. There's quite a few LEDs in here. Here's the circuit board. Let's take a look at it, get some idea of the quality. Put my visor on. Blue, that's nice. Plating is all through hole, which is also nice. The traces look good. They're very thin. Not that that's a problem. There's enough current going through here for thin traces to be a problem. So there are components on both sides. Resistors and some ICs on this side. The resistors and voltage regulators and capacitors do not show the values, but that's okay. Hopefully they have a good build guide, because as you can see, no paper came in the box. And here are a whole bunch of diodes up here, and then tons and tons of switches, and I didn't mention it here, 2 ICs, and again more and more switches, and a bunch of jacks. That looks pretty straightforward. keep the plastic bag because it's got their support email address, which is always good. Let's see what's in this other bag. Let me get 2 parts trays out. I've got a rectangular one and a circular one. You do have a piece of paper. Bill of materials, so 2 voltage regulators, 28-pin sockets, hex standoffs, 4 of them, screws, black screws, LED spacers times 70. That's a lot of spacers. I think they mean LEDs. Euro power cable, eurorack power cable, and a screw kit to mount it in the rack. And then here's the back. Oh no, so I guess they were correct. There are 70 spacers. That'll be fun. A couple of capacitors, bunch of LEDs, just 1 diode. That's interesting. Not much polarity protection. Some jacks, 1 trim pot, resistors, a couple of switches, and the ICs. Now let's look at all the little bits and pieces. Eurorack power cable with a blue stripe, not a red stripe. What rebels they are. Bunch of resistors and variable resistors. 2 green LEDs kind of thrown in there. 2 trim pots. And this says True Green in some text right there. Not sure what that means. There's a whole bunch of the push buttons. I'll put those in that box for right now. In here are the ICs, I'm sure. Mechanical bits, the spacers and standoffs, and screws. Power connector and audio jacks. LED spacers. I haven't done this before. I haven't used these before. I'll have to figure out how that goes together and works. And a whole bunch of LEDs. And that's all that's in the bag. So my next step is I'm going to go, I'm going to pause the cameras and look online. Oh, I see. That's why I have these separated. These are 3mm green, and there's 2 of those, and they'll be in this bag. They're right there. And then 2 3mm true greens, and that's in this bag. Not sure what the difference is. I've never encountered that as a difference, but I'll probably look it up and then let you know what that means. I'm going to see if they have a build guide. As you can see on the BOM, it labels where each part goes, so we don't technically have to have a build guide. So, but I am going to go, and if you look here, this badly printed finish shows where all the colors go. And I'm going to assume the true greens go, true greens go here, and the other greens go on the octave. So I went to their website, and not only do they have a build guide online, but it's actually a rather comprehensive one, which is really nice. Again, you know how I feel about pictures. The more pictures you have, the better. The only question I had was the LED spacers. And they're just there to make the LEDs flush with the front panel. I think I may even use PCB holder for this one. So all this goes aside. We're not going to do the LEDs first. We're going to do the LEDs last. So we'll go into the bag of small electronic parts. Actually, we'll do the LEDs second to last. I think we'll do third to last. I think we'll do the LEDs, then the switches, then the jacks. Because we'll want to hold the switches and the jacks until we're ready to mate the front panel and the circuit board. We just have to, I'm going to put these, speaking of which, I'm going to put the LEDs back in the bag that says True Green so I don't get them confused. So this is hand packed at Division-6, and you can see it's a little piece of blue lavender painter's tape that they laid all the components in, which is a-okay. And we're going to start, as always, most flush to the board first, and there's only one diode, so I want to get that on the board first, because once I start putting components on here, I won't be able to find it. And I'm not able to find it yet anyway. I know it lives here somewhere. So it should be, if I were a diode, I'd be near the power connector, and there it is. Good. Oh, I'm actually gonna solder this one in place first, because diodes need a little solder love. Grab another strand. I know I didn't lock it into the PCB holder, so it's probably going to fall down while I'm doing this. If it falls down while I'm doing this, you can say, "I told you so," and there it goes. Go ahead and say it. Another comment on the board quality, it seems to be the solder pads took solder very well, which is always a plus. Now I'm going to put it in here. Okay, let's take a look at the resistors, and we've got 10 100K resistors. Now this is, I will make a little comment here. They, bless their hearts, they have printed this out in color, and theoretically you could tell what the resistor bands are, but again, this is they were having toner issues when they printed this out. So if you're doing this yourself, you're going to want to check the resistor values yourself. If it says 100 ohm, then look at the colors and either look it up on your color chart and say, ah, yes, brown, black, brown, that's 100 ohm, that's what I want to do. Do not necessarily rely on the colors you see on this chart, because it's going to be different and you'll be sad. Better to either learn your resistor colors, get a little calculator like this one, which I built. You can see this build video from a couple of months ago. It's kind of cute. Let's see, brown, black, brown. That's 100 ohm. I mean, you can put gold, you can put the fourth band in, which is gold, but that's just a tolerance of 5%. So you can get something like that. You can have a regular color chart, or worse comes to worse, and it's not worse really. It's just another option that can help you out, is if you're ever really unsure, just put your meter on it. Doesn't hurt anything. Just double check and say, I'm not sure how much is this. 98 ohms, that's close enough within 5% of 100 ohms to be 100 ohm resistor. And never be ashamed. Some people get like this, they say, I should know, I should have memorized. I've been doing this a long time, like in the 50 years, and sometimes my brain freezes on some of the more odd resistor values, and I don't even put it on the calculator. I just say I put it on the meter, because ultimately the meter doesn't lie. Now, the one thing you will rely on here is where the resistors go. These 100 ohm are R3 to R7, R16 to R20. So what's on the back? Oh, this is the back. So this is R3 through R7. Now, the one thing, since they put them in that painter's tape, there's a little more adhesive coming up on the leads than I like. So I'm going to get some alcohol, get some isopropyl alcohol and a paper towel, and just wet the paper towel down and run the resistor leads through it to get some of this adhesive off there. It shouldn't be a big deal, because the solder and the flux will clean that off, but I just want to give it a little bit of a hand and get some of the glue off there. Resistor values. It doesn't really matter what you do as long as you are consistent. For me, my consistency is first value ring is always to the left, tolerance ring is all the way to the right. When we're going vertically, first band is up, tolerance band is at the bottom. Again, you could do it the reverse. You can do it any old way you want. Just do it consistently, so later on, if you have an issue and you want to troubleshoot the board, you don't have to, you're not going to be confused as to which way the resistors are facing, so you don't know what the values are real quickly. So just be consistent. Same with capacitors. For discs, I go value facing left or down. For disc capacitors, obviously. For electrolytics, I mean disc capacitors and regular foil wrap capacitors, I do that so I can read it that way. Electrolytics, it depends on where your polarity is. And we'll go ahead and put the 2 voltage regulators in also. And you got to be careful, because these are the 2 431s T1s, but you've got the 493150, so you don't want to get those confused. These solder pads are pretty close together, So be careful on these voltage regulators. In fact, because I happen to have it, I'm just going to put a little more flux around these pins just to have a little more protection against bridging. Again, you normally do this with surface mount, but works just as well with through hole when you've got some really tight connections. So I recommend you grab something like this Chip Quick rosin paste flux and have it under your workbench just to grab it in case you need it. It can be a lifesaver in terms of not bridging contacts, because bridging contacts makes you sad. Now I'm going to triple check these to make sure I'm not bridged. So I'm going to lift this out of frame for a second so I can look. And that's another thing to have your meter handy for. It's connectivity. Nope. Nope. See, if they were bridged, you'd hear the meter beep, and they're not bridged. Check the pins, check the notch alignment, drop it in, check flushness. Yeah, that's all flush. And I'm going to turn the cameras off for this because you don't need to see me solder 60-some solder points. Okay, let's find the power connector. Power connector with stripe down and notch on this side. So we'll just set it in there for a second. Now, because we want to be very paranoid, because being very paranoid makes you very long-lived, let's take the actual power cord, look at the notch, and just verify, yep, the stripe is on that side. So we can go ahead and solder the power connector down. It's interesting that he's only got one diode here. Must be, that's it. And that's it. It's the control voltage trimmers here and here. That's the where the variable resistors go. Yeah, go here. That's pretty loose. So you can see the trimmer's accessible. The trimmer's accessible to you through that little hole there. Now, since we're going to be getting into putting the panel mount components on in an upcoming step, we want to make sure we have the right distance. So at this point, the author of the kit recommends that we put the spacers on the board. And so we'll do that. And the spacers are pretty easy to notice. Of course, they're the larger holes with the silver pad around them. Now the next thing is to install all the LEDs. Now, they're very generous in their description, and I like this. I like this kind of attitude. He says, you can put the LEDs in any way you want, color them up any way you want. This is what we designed it for, but if you want to do it something different, go ahead. And I like that kind of approach. I mean, it is ultimately up to you. You're going to be using it, and make it look any way you want. Now, there are two ways we can do this. We can set the LEDs in, and then when we have them all in, we can put the we can put the front panel in, and then adjust all the LEDs and then solder them. They also have provided a back. Yeah, I'm sorry, I got confused as to whether my camera was on. They also provided spacers that you can put under the LED, which should give you the correct height. Of course, it makes it a little easier, a little harder to get that in there. So I'm going to give that a little bit of a try right here and see how it looks, if it really does go flush. In other words, what I'm looking for here is if I put the LEDs on the spacers and then drop the panel on to match the metal spacers. So that does seem to give us what we want. The LED is not protruding more than about 1.5 millimeter. So that could work. I mean, the other option, and you can see these protrude just about millimeter and a half. Now the other option the author suggests is you can shove them all the way through. As you can see there, we've got 3 millimeters up, or 1/8 of an inch, 3/16 of an inch. You can do that also. The author does not recommend that because he has, or she has found that interferes with some of operating the switches. So I'm going to go with the author's recommendation, particularly because these spacers seem to be doing exactly what we want, and just have the LEDs protruding slightly from the front panel, not fully out. So we'll do that. I also didn't video the putting all the spacers on the LEDs. Two things. These spacers are really good. They're not just cut pieces of tubing, but they've got two holes to align the pins. It's nice. The only downside is I appear to have 3 more LEDs than I have spacers. And now we'll go into fast motion as I place all these LEDs. And that's all the LEDs installed. And I was wrong. We did have enough spacers. I was confused because there are 4 extra blue LEDs and 1 extra white LED, and I had put spacers on all the blue ones. So the spacers I didn't think I had were actually on LEDs I'm not going to use. And I ended up with 3 extra spacers as well as some extra LEDs to throw into my collection. Oh, wait, there is one more white that I missed. I'm sorry. So it's just blue LEDs that are extra. But I will throw the extras into my box of extra parts from kits. It's surprising how many extra parts I'm going to be able to build a personal computer in a little bit with all the extra parts that have come in various kits I've made. Now the next thing I'm going to do before I do anything else is I'm going to make sure I got the polarity right on all the LEDs, because that would be sad if I didn't. So I'm simply going to look at them and make sure that the short pins for the blue LEDs are on the bottom, and they are, and on the pins that are going horizontally, the short pin, as I'm looking at it right now, will be to the left, and just verifying that with all of them, because when you're in the plugging things 100 things into the board mode, you can, even though you're trying to be careful, your brain can numb out and you'll miss one or two. But I did not. They're all in correctly. Good. Let's see. Now, of course, it's going to be interesting to get the panel on here and get all those LEDs poking through the right holes. That's going to be... Okay, the author recommends we now solder the LEDs in. So I'm going to do that, but I'm going to do it a little... I'm going to put the front panel on, because this makes sure as I solder all these LED leads, they're going to be all at the same height, all angled correctly, and I won't be sad. You did notice I used my pointy thing to the yellow LEDs were a little misaligned, and I used my pointy thing to straighten them out. But I will say, even with 16, 32, 42, 44, 46, 48, 50, 60 some odd LEDs, it went together pretty dang well. And I credit the spacers for that. So if you get one of these units and you have a choice on using the spacers or not, I would recommend you use the spacers simply to ensure that the LEDs are all aligned when you're putting them through the front panel. Save you a bit of grief. So again, I'm going to solder all these, and you don't need to watch me solder 120 or so LED leads. So I'm going to go ahead and turn the camera off for that. Now we've got all the LEDs in, and one thing that I do want to mention is as you're soldering along on the back, you'll probably push against some pins that you're not soldering currently, and that might push the LEDs forward. Just since you have the panel installed, just run your fingers along the back, and that'll ensure that the panel sits, the LEDs are in the right position. Just do that every time you move to a new row. Next are the switches. Bunch of switches. Fortunately, they're all the same height. I might have done the switches before. I might have done the switches before the LEDs because of the height. The switches are down, nestled between the LEDs and the spacers. So I'm actually going to have to use my needle nose to position them and drive them into the board instead of just using my fingers. And I gotta make sure I'm getting them in there. So that's one suggestion for the kit author, is to do the switches before the LEDs. And this spacer is actually in the way too. This is an interesting one. I mean, you can just push on the switch shaft, but I personally don't like to do that because I don't want to damage it. Now that did not go in all that well. So, as you can see, these switches may need a little coaxing to get in right, but they will eventually go in right. Now again, I've got 20 or so of these to put in and solder, so I'll go into fast motion and probably skip some of it too. In fact, I'm just going to go ahead and turn the cameras off. You don't need to see me fighting with each one of these switches. It just burns time, and people complain about how long my videos are anyway. Okay, we're back live after all, because I came up with a better plan. So what I'm doing, let me see if I can get this. I'm holding the shaft of the switch with the needle nose, but the needle nose tips, these are square tip, are pressing against the base. So I'm not actually putting stress on the switch shaft as I align and drive it home. Now, one thing you really need to pay attention to here is making sure you don't bend some switch legs. I've already bent one, and I'll fix that up and put it on one of these outside positions where I can get at it easier, so I can make sure I do it right. But this can be a little challenging. Just be patient. And then make sure they're all aligned, of course. As you can see, if you drive them in with the needle nose, it's not bad. And again, the author of the kit does say, because it's all through-hole mounted parts, it's a pretty straightforward kit, but he does, or she does, say that it's medium complexity, medium skill level for all the closeness of the connections, like for all those LED connections. And I'm going to add that it's probably medium skill level for positioning all these switches, particularly if you don't have a hugely extensive toolbox and you may not have a good pair of very long needle nose with flat tips. If you don't, I'd put it on your list of tools to get. They're very handy for a lot of reasons. And get good ones. These, again, these are Exolite from Weller, and one of the things that you're paying for when you're getting high quality needle nose like this is the jaws are going to stay parallel and they're not going to flex too much. Oop, that pin's already bent. I'll set that one aside because it looks like I may have extra switches, but we'll see. The other thing about these good needle nose is they're real good for aligning pins on ICs or switches or whatever, wherever you might have pins that need to be parallel with each other and maybe a little bent in shipping or however when you get them. And these are really good for that. Okay, and the author does say for the switches to go ahead and drop the panel on. Okay, much better. Much better. I've got most of them through. The top half is good. Bottom half, the run switch, is out of space a little bit. There we go. Oop. Got most of them. But somebody over here is not cooperating. Oop. I got all them to cooperate. Now the top guys came back out. This is the fun part. Okay, I've got them all. There we go. They're all through. And we'll loosely put the front panel screws in. And again, I'm going to turn the camera off while I solder all these screws in. I mean switches in. Switches are all soldered. Let's take the panel back off again. Should be easier to put on the next time. It's a lot of stuff, isn't it? Now we're going to do the jacks. I'm taking one last look here to see if I've missed any components. I haven't so far. Now we'll put the panel on again. All the jacks seem secure. So I'm going to solder this flat on the workbench so that the workbench is pressing the jacks fully downward. And now I'm going to solder all these jacks, so I'll go into fast motion again for this. Alright, that's all the jacks, and I believe we are done with soldering. So, since we're done with soldering, I'm going to take a look on the back and look at every connection to make sure that everything is soldered. And that all the joints look okay. Yep, everything's soldered, everything looks okay. I think we're ready to proceed. So we're all done. I'm going to do one more thing on the bench. We're going to calibrate the octave. So let me get my meter set up. I'm going to power it from this frequency central. Routemaster. So we're going to be measuring the CV output at note C at various octave ranges. And dialing in the calibration through that little hole. Where's my little flathead screwdriver? It's not in its normal rack place. What did I do with it? That's bad. I put it in a drawer. That's no good. It needs to be always out. Okay, first thing we're going to do is we're going to power it up, and he says sequencer should perform its startup test routine in which all the LEDs are lit one row at a time. Okay, I'm going to turn off the overhead light because we don't need it for this, and we'll want to look at the LEDs. Let's see, power coming on. Oh, there it goes. And everything lit up. And as he said at the end, after the test, the two white clock LEDs and blue step 1 LED should be blinking. And that's what we've got. So both sequencers appear to be working. That's a good first step. I'm not getting any control voltage yet. So let's see, where's the run button? Here's the run button for sequencer 1. And there it goes. And it's cycling through. And let's try the other one. And that's sequencing 2. As you'll notice, they're not synced, which is okay. I'm sure you can sync them, or if you share clock, that'd work too. I'm going to stop that. Stop the bottom one. I'm going to stop the top one now. And so we've got our meter hooked up to CV out on this, and we're going to press reset. And that resets sequencer 1. Good, to make sure it's in ready or program mode. Either will work. Press octave up a couple of times, it says. Octave up until the green light, green LED on steady, which it is. Now press note C. Here's note C. And we should be getting 4 volts. And we're getting 3.928, which is pretty dang good. Let's see how much sensitivity there is here. See if we can get this to exactly 4. Looks like we can. And that's 4. Close enough. I'm not going to try and get rid of that thousandths of a volt, because I could be chasing that. Okay, now we'll go octave down, hit C again, and we're at 3.004. That's good. Octave down again, hit C again. 204 or 2004, that's great. Octave down again, and 1067, that's a little higher. It's climbing up a little bit. Then all the way down to 0. Alright, we're ready to give it some live tests. So I've got it in the rack, hooked up to the 15 watt amplifier I have out here. Now I'm going to move in on the whole thing. First I'm going to give you a closer look. We're going to be using an ADAC VCO, the Patching Panda Punch for a little shaping, the ADSR from Befaco, and the output module from the Befaco to feed the amplifier. Now I'm going to reposition the camera a little bit. Okay, first thing we'll do is see if it makes any noise. it does indeed make noise. Good. So I believe that program's step 1. Now we'll go to step 2 and set that. If the LED's steady, that means you're programming it. Change the octave, see if that actually does what I think it's going to do. Octave again. Okay, now I've got 10 steps programmed. Let's see if it works. Let me go back to... So it sounds like it's done what I expected to do. Now I'm going to turn this down just a hair. Now we'll hit run. And that does what we expected it to do. Now it's flashy light means it's ready, which means it'll start on the whatever step you're currently on. So if we hit run, it won't go back to the beginning, it'll start at step 3. Just like I thought. Good. So we can program it any way we want. Let's see. And then we can add rests. So let's go through our sequence. Step 11 will be a rest. Good. Let's double check that. Yep. Rest note stays in. Oops, didn't want to do that. Now, step 12, what else do we have here? Okay, we can hit set loop here, so it'll loop back. If we go back to 11, which is where I programmed a rest, and hit loop, oh, it can't be both. Okay, we'll keep that as rest, and 12 will be loop, and then we'll have that run. So that all works the way we expect. And then you can do an accent. In addition to a note, accent output can be programmed in any step. So that's output, and I don't have a filter or anything hooked up, so I'm not going to mess with that right now. See, and then okay, so the tempo is adjusted by step when the sequencer is running. Obviously, it's got clock in if we want to do input our own clock. So let's go ahead and run this that way and increase the tempo. Works. That's really nice. I like it quite a bit. The transpose CV, I have to figure out if I have anything that I want to hook up to make that sound good. I'm actually going to change my ADAC to doing a sine wave just to hear it slightly differently. Okay. Okay, great. Works well. It's got two sequencers, top and bottom. You can chain them if you want to play this sequence, then fire off this sequence, so you can get 32 steps, which is really nice, or you can run them complementary, of course. And it's really just a happening thing. I like it quite a bit. It was, as we saw, there was a lot of soldering involved, and there's a bit of tight tolerances on some of the soldering, so it's not necessarily a beginner kit. You have to be careful with it. But it was easy to put together. Surprisingly, getting all these parts, all these protrusions through the front panel was not as bad as it could have been. And I'm pretty happy with this. I recommend this little mini sequencer. So that's it for this evening, and I hope you enjoyed this video. See you in the next one.